Hello students, a very warm welcome to this current and electricity 10 years PYQ discussion. And so what is the speciality of today's session? Today we are going to discuss multiple ways to solve your problems. We'll be doing some kind of concept revisions. So you may want to take down the important formulas around your problems, and as well as understand the tricks and the techniques to solve quickly the questions in your exam. So today's session will be also having a short concept revision around some of your main theories, and we'll be doing that in today's session. Let's get into this lecture. It's going to be a super interesting, very easy lecture. And one more important information, students. So from tomorrow onwards, we'll be having a PYQ discussion around your this chapter, like gravitation chapter as well, from 6 p.m. So you can also start attending them. So this is going to be running on your side track. This is actually as a part of your 2022 aspirants lectures. Will be doing that PYQ session. So 2021 aspirants also can now attend it and do a kind of concept revision. But try to complete last 5 lectures 2021 aspirants of gravitation, because those are the topics from which you typically get questions in your exam. The last 5 lectures, I would say, like from lecture number 17 to 23 or like 18 to 23. And that being said, students, I'm Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. And I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I have filed 25 patent applications in India, US and Canada. And students, yes, not only that, the other amazing thing about myself is that I'm an electrical engineer, and you are going to explore all of those things with an electrical engineer. So don't worry about it. It's a current electricity chapter. And students, that being said, if you are looking for an amazing platform with the best educators, like a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription. So what do we have on Unacademy subscription? We have the best educators across the nation with whom you can attend daily live interactive classes on a very interactive platform with live polls and leaderboards. And in fact, we have authors like DC Pandey and DC Gupta sir on Unacademy subscription platform. And you can attend live test series set by the best educators. And these are all going to be like national level test series, post which you'll be getting analysis using which you can improve upon your overall performance. And you'll also get access to lots and lots of live doubt clearing session, and every program on Unacademy subscription is going to be structured. You don't have to worry about the planning. It will be taken care by us. In fact, every program is going to have the 4th session as live doubt clearing session, and we will also have lots of quizzes and mega quizzes with each and every program. And not only that, Unacademy subscription, as another amazing thing, we do not restrict you by any batches. It's unlimited access throughout the period. You can enroll to as many batches as you want, but 2021 aspirants, be careful about what you're doing. And the thing is, how do you log in and how do you avail an Unacademy subscription? First of all, download an Unacademy learning app. You need to log in using your user ID and or your phone number and password, and then you'll be hitting on this plus button, and then hitting on this IIT JEE as your goal, and then hit on this get subscription button. And yes, students, yes, that is another thing is like we have dedicated batches for 2021 aspirants as well. So I'll be discussing those things at the end of the lectures. So if you're looking for one such thing, you can stay and tuned until end. But anyway, do stay until tuned until end so that you understand this lecture really well. And who should be going for what kind of subscription? So let's say you are a 2021 aspirant and you have no plan for drop. Okay. So no drop, 2021 target or 2021 aspirant, 6-month program is for you. Okay. 6-month program is for you. It's going to cost you near about 25,250 for 6 months. Okay, so it's going to be a reasonable package, and of course you can also go for a 1-year package if you have any plans for drop. Let's say you are a 2021 aspirant and you are planning to drop, or let's say you are a 2022 aspirant, that is like 11th class student, and you're sure you can complete your preparation in 1 year. You can go for that as well, and you'll get a 12-month subscription at a price of near about 34,650. That's like less than 2,900 per month, 2,888. And if you are going to get into 10th class or 11th class, that is like you are either in 10th class or 11th class, or you are a 2023 aspirant. Okay, go for a 2-year subscription. A 2-year subscription is going to be the most reasonable one, and in fact we have started some batches by some of the best like coaching institute, that is like Vibrant Educators, etc., on Unacademy Plus, and that has been launched very recently. And even for 2021 aspirants we have started some of the best batches. Even for 2020 aspirants we have started some of the best batches. And coming to the pricing part, how much it is going to cost you, like near about 50,000, like 25,000 per year, 50,000 for 2 years. That's going to be less than 70 rupees a day. So this is about plus subscription. We have something beyond plus subscription known as your iconic subscription. What is this iconic subscription? Why do I say it is beyond plus subscription? Because you will get access to personal mentoring session, one-on-one mentoring session, personal advisors, like guidances, etc., from IITians and NITians who are educators on Unacademy subscription platform. So students, this is an amazing thing, amazing opportunity where you can get personal advisors, you can understand the strategy for your preparation. So here the educators will be taking up motivational sessions and providing you strategies for your preparations for your exam. So think about it, IITians and NITians who have previously gone through this journey or aiding you in this journey with efficient strategies for your preparation. So that can happen on iconic subscription. That is a specialty of Unacademy subscription platform, and the pricing is also going to be reasonable. If you go for a 6-month subscription, it's going to cost you less than 35,000, 34,200. If you go for 1-year subscription, it's going to cost you 58,500, and if you go for a 2-year subscription, it's going to cost you 90,000 for 2 years. That's like 45,000 per year, less than 50,000 per year for an iconic IIT JEE subscription. And make sure you apply Murali Live code to get the best maximum discount on your subscription purchases, students. So right, that is possible on Unacademy, that if you don't see this price, apply Murali Live code and avail maximum benefits. You can unlock many features, be it you're going for 6 months, 12 months, 24 months plus or iconic subscription. To get maximum discount, do apply Murali Live code. And not only that, students, we have recently launched something known as combo subscription. What is this combo subscription? A combo subscription is nothing but one subscription for both your JEE and your CBSE board preparation at a very economical price. So yes, it is one place where you can prepare for your JEE and CBSE board. From this one platform, you can do it with the best educators across the nation. We in fact have even best educators for your CBSE preparations, for your CBSE preparation on your Unacademy subscription platform. So that's the beauty of an Unacademy subscription. You can get a combined subscription at a very economical price at less than 90 rupees a day. If you go for a 2-year subscription, if you go for a 1-year subscription, it's going to cost you less than 120 rupees a day. And make sure you apply Murali Live code. You're going for either even a combo subscription so that you can get the best discount. There are discounts also available on your combo subscription. Make sure you apply Murali Live code and get that discount. Okay, don't miss out the discount. Alright students, let's get into today's topic. And before that, yes, we are almost nearing your exam, and have a plan in mind, have that confidence. If you think if you can do it, no one can stop you from achieving your success. But given that you move very smartly, you have some strategies, you should have some definite strategies. You should have a plan at least. Okay, strategies are secondary, plan is primary, and your confidence is the utmost important thing. Okay, even if you have a plan, if you don't have the confidence and if you don't have the mindset to put in that kind of effort and to focus on your studies right now, it's going to be really a tough thing. So do have a plan, do have that confidence. There is no substitute for hard work. This is the time to work hard and as well as to work smart. That is what we are going to discuss in this PYQ session whenever and wherever possible. Let's get into this amazing question and this amazing lecture. And one more important thing, do not forget to like and share this video, students. Do definitely share it on your social media because the exam is approaching. 2021 aspirants need them, so do definitely share it. And what is this question? This question is where we almost entered yesterday. I told you I'll also give you a kind of an explanation around this thing. So a cell of internal resistance R drives current through an external resistance R. The maximum power is supposed to be delivered to the resistance. How would that be possible? How do I change the external resistance such that the maximum power is delivered to the external resistance? And as you know, the answer should be, so this is basically based on a theory. Okay, I told you this theory is used in multiple places, not just in this thing. This is known as maximum power transfer theorem. Remember this. Okay, I'll give you a short description about this theorem. It's a famous theorem. It's a famous theorem. Even if you get into, PhD research, you're going to study this theorem. You'll be matching the impedances instead of resistances, but you'll be studying this theorem. This is derivable. Okay, that is why this works. This is how it works. So let's get into this thing and let's understand everything. And I'll also give you some examples of how to work around different kind of problems around your maximum power transfer theorem. But expect questions from MPT, maximum power transfer theorem. It's possible that you will get questions from MPT. Okay, so it's a simple question. So let's say you have a battery and you have an internal resistance and you have an external resistance. Okay, now comes the thing. Okay, now comes the question. Okay, I want to give maximum power to this guy. Okay, we'll be deriving it for or calculating it for just one case. I'll be explaining the rest of the cases. You should be applying the exact same thing. We'll be taking up, in fact, one model problem, out of the randomly, and we'll be discussing it. Okay, so how much current should be flowing in this case? I current. Okay, so how much is I current? EMF divided by external resistance plus that of internal resistance. This is internal resistance, this capital is external resistance. Okay, we have the first thing. Now what is the power? Power is I square R. We have two things that we know. Okay, that means basically EMF divided by R plus R whole square into that of R. Okay, now think about it carefully. Whenever you're given question, you're not going to derive it. You're going to basically say the same thing that what I told you. You must be matching the internal resistance with external resistance, internal impedance with the external impedance to get the maximum power. Okay, now let's do a thing. I need maximum power. What do I need? I need a max power. This should be maximum. How do I do this then? Then say dp by dt should be equal to 0 simply. In this case, sorry, dp by dr is equal to 0. My mistake. dp by dr is equal to 0. So for what value of resistance you will be getting it? Okay. So that's it. Now if we do this, what do we get? Hello Imran sir, hi. And so this should be the term, and this is going to be like, so this is going to be d by dr, I guess. That's it. And there we go. You need to differentiate this term here. And what do we say? This is equal to 0, right, for maximum. Okay. So let's get started with this differentiation. That's all we need to focus on. So you'll be getting the same thing that we just discussed. If this is a way to go about it, but this is only going to be efficient if you're dealing with like very one resistance or something. If you have multiple resistance, how you're going to deal with it. Okay, so we are going to say differentiation of this I squared R power with respect to R. You have E square, and what do you have? You have 1 divided by R plus R whole square into that of R is equal to 0. That's it. And now this EMF is a constant term, so this is not changing. You can basically forget this term. Now what do you have? You have something like, you're going to differentiate two terms. This is like F1 and F2. Okay, so d of F1 into F2. So d of F1 is how much in this case? Minus 2 into that of R plus R whole cube. into that of R plus of, again if you differentiate this thing, it's basically 1, and then we have R plus R whole square. That's it, you got the answer. You go. Okay, it's a simple question as such. MPT is a simple. This term gets cancelled out. So if you solve this, you'll have something like 1 by 2R. 1 is equal to, if I take this on the other side, this is going to be 1, right? So 2R by R plus R is equal to 1. 2R by R plus R is equal to 1. Yeah. So R plus R is equal to, there you go. So this is like a fact that we derived. R is equal to R. What is this known as? MPT, maximum power transfer theorem. It's a direct question from MPT actually. This is because this has a lot of applications practically. Practically, it has many applications, students. Okay. Now let's get into the next thing. Okay, I told you, right? We'll be discussing few things. So let's say you have something like this, R1, and you have something R2, and then you have something like R3. Okay, and that's it. Now for now, let's just deal with 3 resistors. This is a network. This can be like an electrical circuit. Now what we are going to do is, we are going to say there is an internal resistance. And you have, of course, a battery. A battery having both of this. Now the question is, let's say you don't know R2. R2 is equal to X. Value of R1 is given, R3 is given. Now they ask you to find out value of R2 such that maximum power is transferred across the network. Okay, now what do you do in such cases, students? Basically calculate equivalent resistance and say that this equivalent resistance is going to be equal to R internal. Now it's basically these two in parallel and in series with this, right? So something like R1 in series with, in this case you can directly add, but we'll be using the sign. Okay, R1 in series with something really very simple, that is your R2 and R3 in parallel is equal to how much? R internal. Okay, so your value of R2 you can calculate it if you want to do that. Okay, so if you think about it, so this is going to be how much? This is going to be R internal minus of R1, and just giving you a quick understanding of how do you do work around things. You don't want to exactly follow this thing. Basically what I'm saying is resistance of the network. Okay, that is what MPT is saying, right? Not me, but resistance of the network. That is like the external resistance, right? Total external resistance. If total external resistance matches your internal resistance, maximum, okay, it can be also total internal resistance. In fact, we have a problem coming up. That's why I'm discussing this in detail. Okay, total internal resistance. Then what happens? Maximum power is transferred. If this condition matches, what is happening? Maximum power is transferred. MPT, maximum power is transferred. just to give you a quick understanding of things, because we have one more question, so I don't think that should be an issue. So you can typically note down these questions like this. It's like 1 by R2 should be equal to 1 by R, just giving you a shortcut, but maybe you want to apply in the exam depending upon if it's a number, you want to probably do it directly, but still this is according to me a very easy method of doing, you reduce it this way and you come up with the answer. This is just a sample thing that I'm giving you, but you need to make use of your own thinking at that point of time and come up with some answers, come up with some solutions. That's about MPT. That's MPT. MPT direct question, you got it in 2019, 2017, JEE Advanced, so many times in JEE Mains, so many times also in JEE Advanced, different kind of questions, but many times. Even in 2019, multiple times this thing was asked. Not the same question. I don't know if the same question was asked, but multiple times this thing was asked, like in different forms as well. Okay, let's get into the next question. There is of course another MPT question coming up very soon. This is a simple question. Students, get started on this. This is something that you should be doing it yourself. It's not at all a big deal, as you know. What is being asked? What is the current drawn from the battery? Simple question. This is like the cakewalk question. Such questions, you should be only careful of one thing: calculation. Other than calculation, you need not worry about anything. Literally, you need not worry about anything. Let me just have a look at this, and I'm thinking if any shortcut does exist in this case. I think there exists a shortcut. Okay. How much is 15 by 20? Not even going to be 15. Going to be something like there are two half. It should be less than half. Okay, it's option 2 is wrong. Easy. I have a shortcut for you. Let's get into that shortcut. What I'm going to say is basically a shortcut. We'll get into the detailed solution. Think carefully, because these kind of questions you want to do it carefully because you don't want to lose the marks. Okay. Typically these kind of questions you should be doing it. Don't be dependent upon shortcuts, but I'll discuss the shortcut. So here comes the thing. How much is okay? I'm going to just label all of them. I'm not going to solve the network. I'm not going to solve the network, students. Notice the thing carefully. I'm basically not going to solve the network. Okay, R6 is how much? 30 ohms. That is fine. R3, I'm writing it down to be 20. I'm just giving the numbers now. We have to do it quickly if it's an exam, so think about it. And R5 is like 25. Now coming to this point, and what about EMF of the battery? 15 volts. What I'm going to say, just listen to this thing very carefully. Okay, this is a large resistance. 20 ohms, 5 ohms and 25 ohms in series, basically like 50 ohms in parallel to 10 ohms. But your final answer is going to be less than 10 ohms, isn't it? Here the final answer is going to be less than 10 ohms. For now, let's do a thing. Let's forget this network. Okay, let's just focus on this network. Quickly, we can come up with the answer. What is the, potential drop across this? It's not even 5 volts, right? Total resistance is like 45. This is just 10 ohms. This is going to be less than 5 volts. Carefully listen to this thing. You will get the answer. Okay, even without diving deep into your solution, like solving that network. So this is a technique that you can apply if you typically understand this method. Okay, total of this is 45, 10 and 30. I'm not solving the network. Okay, I just forgot this network for a while just to find a shortcut. So this is going to be 15, 30, 45, 55. So this guy is not even going to have, like, among this 15 volts, even if these three resistances are present, this guy is not even going to have 5 volts. He's going to have, like, this R2 is going to have anything less than 5 volts. Okay, that means how much current should be flowing through this? Okay, it should be something like 5 by 10. So less than 0.5. In fact, less than 0.4. You can confidently state it's like less than 0.4 actually. you're observing it carefully, it's less than 0.5 amperes. If this network or this resistance is going to draw less than 0.5 ampere, combination of this is probably going to draw less than 0.4, 0.3, something like that. If you understood this is 0.4, this is going to be point. I've not done any calculation up until now. Somewhere the answer should lie between 0.4, 0.3, okay, something like that. Okay, now analyze the option. 7 by 18 near about 0.5, 20 by 3 6.666, 9 by 32 it's near 0.4, 0.3, 13 by 24 near greater than 0.5. Answer should be okay. This is one of the approaches, okay, shortcut for solving such question. Okay, now let's get into just forget the shortcut. Even that way it's an easy question. The only thing is you have to be very careful about, students don't make this mistake. This is a cakewalk as such. You have to be very careful about your calculation. Other than that, you need not worry about anything. Okay, keep it in the simplest form that you can solve as possible. Okay, that's what I'm going to do. See, if I have one such thing, I'll be right while I'm doing it in the exam, I'll be condensing down things very quickly. Okay, whatever is just necessary for that moment. So how much was R3? 20 ohms, and this is how much? This is like, I think 5 ohms, and this is how much this is how much? R5 is 25. Okay, now coming to this point, so if you are wondering, I told you 0.3 etc. So is it for the entire network? Yes, right, it's for the entire network. If this much is dropping around this, how much about the entire network? Respective voltages will be dropping, current will be the same. You don't get confused at that point. I discussed it for that one combination of network, which is basically the current flowing through the network. Okay, R2, we have this to be 10 ohms. I forget rest of the things. I just have to do one thing, replace this guy first, which is a simple question. Just be careful. That's it. If you're not careful enough, you'll miss out the things. Instead, we are going to have 50 ohms. I can forget this, and this is 10 ohms. What is the parallel combination of 10 ohms and 50 ohms? 50 into 10. So R dash, let's keep it as R dash. It's 10 into 50 divided by 10 plus of 50. Okay, then we have something like 5 by 6 or 50 by 6. My mistake, it's 50 by 6. Okay, or like R dash is going to be how much? 25 by 3 if necessary. I don't know if which is easier, but I would probably write down both and later on have a look at it, because I'm to getting started with you. While even guessing the solution, I'm getting started with you. I don't know whether that is the solution as well. We'll see if that comes out to be solution. Okay, and now this equivalent network needs to be drawn. Okay, so it's a battery, and then what do we have? So basically, if you have understood, it's that R1 and R6 in series with this R1 15 ohms. And this is 25 by 3 ohms. By now you must have understood actually what is the current from the battery. 25 by 3 is how much, students? Like anywhere around, even understanding it for one network could have been good enough in this case actually. From the given options, I think even understanding for one network could have given you the answer. But potential drop is more accurate way of assessing the answer. It's not about just, you cannot directly say it from the given question using just one network unless you're doing potential drop, because potential drop is kind of an an estimated answer, but a near about a real estimated answer. Okay, so 25 by 3, you can take this to be anywhere around 8 or like, even keep it to be like 10 and see what is the answer. It should be little less than 10. You can keep it to be 10 and 15 and get the answer, but let's do it realistically. So you add up all three of them to get the R equivalent. Okay, so basically R equivalent of the network is going to be 15 plus 5 plus of 25 by 3. So that's going to be 20 plus of 25 by 3. I think 50 by 6 couldn't have been easier. Could it have been easier? I think that could also help us. Okay, anyway, that's not a big deal. So I think this is 60 plus 25, 85 by 3. Is that correct? Are we doing it all correct? No, we are doing something wrong. What is that thing wrong? It's not 5 ohms. Basically, that's why you need to be very careful on this. It's 30 ohms. Everything is going wrong because of the 30 ohms. Should have been 30 ohms. Let me correct this, and it should have been how much? 45. Add this both, it's only 45. And how much is this going to be? 45 into 3, 135. 135 plus 25, 135, 140, 160 by 3, near about 50. Small mistake can mislead things. That's why I'm being very cautious. I do a cross check in such questions because this is a cakewalk question. You don't want to miss out this question. So now we are concerned about what? We are concerned about battery having 15 volts and your R equivalent having, you know this thing, rest is cakewalk for all of you, isn't it? It's a simple question. Now there is no more complications associated with this question. As such, it's not a complicated question, and I have also given you the shortcut to work around these kind of problems. You know, assess for one simple network and you get the answer. Current through the battery is going to be how much? 15 divided by, I don't know the answer actually, to be honest. I need to calculate it just like how you are doing it right now. This is very complicated, students. Okay, 32 and this is 3, and what do we get? The current to be from the battery. This is 32 is not on the denominator, 32. Okay, so 9 by 32 of an. Okay, let's verify whether our shortcut worked. I'm not sure. I don't even remember whether that was. I think let's have a look at it. But I think whatever we have done right, that shortcut should have been correct. Okay, we'll see such shortcuts in multiple places. I think this is an accurate answer, right? I don't even have to be worried about this. That our guesses could have gone wrong, but this is correct. I should be confident about it. It's 9 by 30. Okay. Alright students, let's get into the next thing. Yeah, 9 by 32 of an amperes. So yeah, you can think about it the way I told you. 1/3 of an ampere is what should be flowing through that specific thing. That is going to be the whole current, right? Really simple shortcut. Now let's get into the next question. Can we use a similar thing in this as well? Think about it a little carefully. Maybe yes and maybe no. Actually, yeah, that is also possible in this case as well, right? So, okay, determine the charge on the capacitor is the question. Okay. So now the thing is, what is this? What is being asked? What is the? Okay, this is again a method of guessing. Beware of method of guessing. I would definitely love to say that thing, because you're guessing it. Finally what happens is that might not be the right answer, and if there are answers nearby, that might not be the right answer. And these kind of questions you don't want to take the risk, because these are like easy questions. You know the answer, you're not going to give up on such questions, right? These are like questions that you know the answer, you should not be giving up on such. Okay, let's get into this. So think about the shortcut, whether it works. Let me also have a look at it, maybe like 30 seconds to have a look at it and guess whether the shortcut is going to work. Okay, so that should be like 7 into 4, 28, 28, 10. It should be like that. Yes, of course, it's an easy answer. Answer should be like 200. Okay. Saying this, it's 200. I guess like you should be trying it as well, using short. Okay, now let's get into this. See, this is 10 microfarads. Q is equal to CV, potential across this, basically potential across this 10 ohms. Is that what it is? Okay, forget everything. Potential across 10 ohms is going to be less than potential across 4 ohms. We know that thing. This equivalent of this both 4 ohms and 2 ohms, 10 ohms. I'll get to the concept. If you don't know the concept, don't worry about it. But I'm just discussing the shortcut. And this 12 ohms and 4 ohms, it's going to be how much? It's going to be something like, I don't know, like the combination, but it's this value should be less than 4. Okay, overall, the net combination R dash is going to be less than 4. If it's less than 4 ohms, let's take it as to be like 3 ohms or something. And then in that case, but this is going to consume anywhere around 80% of that potential drop. Okay, that's one other thing that I know. So this is 6 ohms. This is, let's take it as 4 ohms for now. It should be less than 4 ohms. And that is how much? Anywhere around 72, 4 by 10. So 4 by 10, it's going to be like 7, like 7 into 4, like 28 volts and odd is what we are getting around this node. Okay, it's not 28. It's not 28. Okay, it's something else. Okay, we need to calculate that. Just a guessing method. Okay, and this is going to be like 80% of that 28. So it's going to be near about 22 volts and odd, or 20 volts and odd. 20 volts. How much are we getting? It's like 22 or 22. We can take it as anything, because I know 20 is because 200 over here. That's the answer. Same method. Now let's check why rest of the answers cannot be correct. Okay, if rest of the answers has to be correct, this combination, right? This 4 volt and what can be the, okay, this is one of the things that you need to really understand, well, students. Focus on this thing. We'll be using this in like the upcoming problems as well. What I'm saying is, this is greater than 4 ohms. There can be a situation where this is equal to 4 ohms, the one in parallel. That is the worst possible situation. So the combination is going to be 2 ohms. Okay, 2 ohms is going to be the worst combination, like worst possible situation. Okay, at 2 ohms, carefully think about it. If this is just 2 ohms, okay, that is the worst possible situation. And this is 6 ohms. 6 ohms, 2 ohms, what happens? 2 by 8 into 72 is going to drop across it. This is like 18. 18 volts. If I'm talking about this particular thing, let me erase this, the earlier trick. I'm talking about a new concept, like this concept. It's a concept basically. It's not like a pure shortcut or guessing from the options. So this is going to be how much? Like 16 volts and all. Worst case 16 volts. Worst case 16 volts means okay, not this. Worst case means not possible. That could be the least possible value. Okay, this is 16 volts means this could be 160 microcoulomb, something greater than 160 microcoulomb. What about this 10 microcoulomb, 60 microcoulomb, 2 microcoulomb? So only possible answer is 200 microcoulomb. Even step by step, it's not a big deal. You should be knowing the basic concept. So the basic concept around capacitor says, okay, this in the steady state is going to be like open circuit. Okay, this is going to be like a open circuit. Now the thing is, you know what, it's going to be an open circuit. Now what is the next thing that we need to do and understand about this? Okay, it's an open circuit, open circuit, open circuit. That means whatever potential is being dropped across this 10 ohms is going to be the potential across the V capacitor. That is when no current is going to flow into the 10 microfarad capacitor. Moving very conceptually, huh? This is something that you know. Now, the next thing that we want to understand right now is what is the potential across 10 ohms. So you can kind of forget this capacitor exists and just calculate it. Okay, that is the next thing that we want to do. A simple concept as such, also you can solve it very quickly. How much is the series combination? Well, if you forget this capacitor, this is basically 2 and 10 in series. So that's going to be 12, and 12 and 14 are, sorry, 12 and 4 are in parallel. Okay, if you remember this, 12 4 yields what? 3. This yields 3 ohms, right? Hope you remember this. 1 by R dash is equal to 1 by 12 plus of 1 by 4, which is going to be 4 by 12, which is going to be 1 by 3, and this is going to be 3 ohms. Okay, so what do we have now? Basically the equivalent circuit. Okay, I'll come back to this page. We have 3 ohms. Now I'm going to draw a new circuit. This new circuit as same battery. Okay, 6 ohm resistor and a 3 ohm resistor. What are we concerned about? The potential across the 3 ohm resistor, and even among that we'll be concerned about just that. Okay, so this is the potential that I need. So if this is 70, what is the potential across 3 ohms? Potential across 3 ohms, which is nothing but equivalent of this. Okay, potential across 3 ohms is going to be 72 divided by 9 into 3. Basically in series, is that it? Yes, 6 plus 3. 9 is twice 6 plus 3. Okay, I hope you know this thing. So this is going to be like 2 4 24. Okay, 24 volts. I think we have guessed it. We guessed it correct. Okay, we guessed it correct. I just proved it using that 4 ohms thing, even if not guesses. So that was like from the options though. This is the exact way of going. So this network is going to have 24 volts on it. So that means how much is the potential drop across these nodes? Across these nodes, that is across these nodes, (24 volts) is dropping. That means what about potential drop across 10 ohms when 2 ohm is connected in series? Potential across 10 ohms is going to be 24 volts plus of divided by 10 plus 2, that is like 12. Okay, let me write down the whole equation. Okay, 12, and this is going to be like 2, so it's going to be 20 volts. End of the story. What is the potential across your capacitor? Okay, never miss out this kind of questions unless you are sure about the shortcut. Okay, this is the potential across capacitor. Now C into CV is going to give you how much charge? Okay, so that means how much is this? Capacitance is 10, it's 20, it's 200, basically 200 microcoulomb, because your capacitance is 10 micro. Okay, easy, simple question, students. That's it, not a big deal at all. Okay, let's get into this. Is again an amazing question. Again, shortcut exists. Think about it very carefully. Shortcut exists. Same trick that I've told you earlier. Same trick. A wire of resistance R is bent to form a square ABCD. Okay. A midpoint E is taken between D and C. And what are they asking you? What is the resistance between EC? There is a shortcut. Definitely a shortcut. Super shortcut, easy shortcut, no, nothing much to think, that kind of shortcut. You need to think about it very carefully. That's the key point. Okay. What is the shortcut? Where does the shortcut lie? What needs to be done? Shall we get into it? Get into the shortcut. The total wire ABCD is R. That means each side is going to have R by 4, R by 4, R by 4. Since length by 4, length by 4, length by 4. Okay. Cross-sectional area is remaining this. Yeah. Whole thing is R by 4. The whole thing is R by 4, between E and C, how much it is? R by 8. Correct? Okay. Now, let me ask you a question. Again, I'm going to go back to the same thing. Worst case. Okay, this is greater than R by 4, right? There is an R dash. Okay, this entire thing is R dash. Think about it carefully. The entire thing from ear to ear is R dash. Okay, R dash in parallel with R by 8. Worst case, saying that R dash, you already know R dash is greater than R by 8. So the worst case could be where R dash is same as R by 8. Okay. R dash is same as R by 8. If it's R by 8, what should be the value? R by 8 in parallel with R by 8, that's going to be R by 60, R by 2. Okay, that means this value, R dash, R by 8 value should be always be greater than R by 60. Okay, should be always be greater than R by 16. And at the same time, you know another thing, this combination, let me put it out this, I hope this thing is clear. At the same time, this combination should be less than R by 8, because R by 8 is a resistance in parallel. Okay, you have both this information. Any given network, you can calculate it. Okay, so let's say which of the values are greater than R by 8. Let's eliminate those. R is greater than R by 8. It's of course not going to be R. What about 3 by 4 R? It's also greater than R by 8. This is like 0.75 times of R. What about 1 by 16 R? 1 by 16 R is basically greater than R by 8, but if you look at it carefully, it's that worst possible value, R by 16. Okay, so answer should be 7 by 64. Let's do this. It's not at all a big deal. It's a very simple question. As such, you do the same thing. This is like you say between D and D. It's a simple question, even if you solve it, but this is a popular question. Popular means popular. You in 2019 paper, you got anywhere around not just one, not even two, but 3 or 4 questions around this concept. What is the concept? You will have a wire, you will bend it, and in the form of circle, in the form of square, or it can be like even polygon, like hexagon, etc. And you should be finding out the resistance between the adjacent nodes, opposite nodes, diagonal, etc. And there is one other situation says that you'll elongate the wire. Okay, that will come to the kind of model problem soon. Okay, so now in this case, what should be, this is r by 4, what did we do? This is r by 8. I'm really sorry, this is half of r by 4, right? This is going to be what? R by 8. We just discussed this point. So r by 8 in parallel with, this is series combination of r by 4 plus r by 4 plus r by 4 plus of r by 8. How much is that? Like 3 r by 4. So r1 is going to be like 3, basically 7 r by 8. Is that it? Yes. 3 r by 4 plus of r by 8. Okay. Now next thing, we have r2 to be how much? This thing, r2 to be r by 8. Okay. R1 to be 7 r by 8. What is correct? What are we supposed to do? We don't have a network like in series, we have a network in parallel. So we have something like this. You're understanding this point. Okay. Now, how do we find out this thing? It's very simple. It's basically parallel combination of 7 r by 8 and r by 8. Let's move on to the next page then. Okay. So, what do we need to find? R effective, R net is how much? Parallel combination of 7 r by 8 and r by 8. This looks little, let me just correct it. It's the same thing. I'm going to write down the same thing, but let's use the parallel sign if you remember this thing. Okay, so this is going to give you how much. One thing you can do is you can easiest one would be like multiplying them. You're not even taking an inverse. 7 r by 8 into that of r by 8 divided by 7 r by 8 plus of r by 8, because in this case 7 r by 8 added is going to give you r. So you'll be having something like 7 r by 8 into r by 8 is going to give you, on the denominator r is going to give you how much? Basically 7 by 64. R net should be 7 by 64. You got the same answer. Simple, easy, logical, and no strain question. Okay, very easy. All right, let's get into the next question. This is again an electrical instrumentation question. Students, the electrical measuring instruments in one shot is available for free of cost as a special class. In the single go is available for free of cost on a special class on your Unacademy learning app. You can complete it. So what does the question say? A moving coil galvanometer has a resistance 50 ohms. It indicates a full deflection of 4 milliamperes. A voltmeter is made up of this galvanometer and a 5 kilo ohm resistance. The maximum voltage that it can measure is how much? So without confusion, you can do the problem. I don't think any shortcut is required in this case. It's a very simple thing. But if you're noticing, it's all 10 like 15, 20, 40. Probably in this case you can ignore the resistance of galvanometer. Simple one line question, that's it, that's all it is. So what I'm saying is maximum current. Okay, drawing the circuit, this is the maximum current that this guy can handle. Anyway, next question, soon we are going to get into ammeter as well, so let's we do this. So what can be this maximum thing around it? It indicates a full scale deflection or full deflection of 4 milliampere. So what can be the maximum potential across them? Max potential, as you know, is going to be, because this is current max, going to be current max into that of like 50 plus 5 kilo ohm. Okay, 5 kilo ohm is like 5000. So this is how much? 4 milliampere, 4 into 10 to the power minus 3 into that of how much do we have? 50-50. Okay, and if it's 50-50, what do we have? You know, actually it's 20, very easy to guess right away from here. But if you are doing it accurately, not necessary though, because it's not asked in the question that accurately. So the concept is, you will be saying if x is greater than g, then you will say x plus g is approximately g. But sometimes questions can be, so you need to be a little careful while solving such question. So there we go. We will have something like 20.20 volts, approximately 20. Okay, now what is the concept behind this? Any other concept, any other exceptional concept is there behind this? Yes, we need not have complicated it too much. We could have said this is G and R, and if R, let's keep it as not even R, the most used term is like X, let's keep it as X. So X, so we say that if X is greater than G, then V max is basically just I max into that of X. Okay, that's it. One more explanation could be X plus G is approximately equal to X itself. End of the story. Simple question, students. No complications, simple questions. That is what you have it. Basically one line question. Okay, again I told you another similar question, but read this question carefully. If you're able to solve this question right, you have done a great job. Literally done a great job. Is there a shortcut around this? There is a shortcut, given that you understood the question clearly. Okay, you need to carefully understand the question to come up with the shortcut. That is the point. So a metal wire of resistance 3 ohm is elongated to make a uniform wire of double its previous. So what have you done? You have doubled it. Doubling the length is going to do what? Make your resistance 4 times. Okay. Make your resistance basically. So this is how it works. This 3 ohms becomes 12 ohms. I'll come to that point, how this comes and all. Students who want to quickly know how to work around this problem, this is how it's going to be. 2/5/2 ohms. Okay. And then you have a 60 point. Okay, actually this is a very easy question. Okay, and then you will have like 10 ohm and basically like R by 36. Is that what it is? 5R by 30. So 5R by 36, 60 by 36. 60 by 36 is how much? So 60 degrees, right? 1/6 of this. Just like how we saw in the earlier problem. So this is going to be how much? The net value is going to be like 5R by 36 actually. 5R by 36 is going to approximately give you, we need not do it approximately like 5/3. There's no 5/3. Basically, I think one option should have been 5/3. Let me think about it once again. I think the answer should be 5 by 3. Answer should be 5 by 3. Okay. Oh, no issues there, Varun. No issues. We are yet to get into. We have discussed some techniques today, Devra. So you need to complete that as well, Varun. You need to complete that thing as well, Varun. Other than that, I don't think we have done anything much today. But basically, solving questions very quickly is what we have done today. You need to definitely go through those techniques, students. Those are for your exams. So this also for your exam. But anyway, this 5 by 36 is going to be like 5 by 3. So let's get into the detailed solution and understand how this all works. So first of all, very popular again. Okay, this is actually a combination of two popular questions. Okay, model problem, very popular model problem, often asked in your exam. There is a 3 ohm resistance. So what happens is you will have a wire. Okay. This wire initially had 3 ohm resistance between its. Then what you do, you do a crazy thing. The crazy thing is elongating this wire. You elongate this wire such that now it would have nothing new is added to it. So you elongate this wire such that, oh my goodness, you elongate this wire such that this has become 2L length. Okay, you need to understand one thing. The basic concept is the same in all kind of questions. Understand the concept. It's a very simple thing. Okay, and this as an area A. Okay, now the thing is, think about this area. How much is this going to be? A dash. How much is this going to be in comparison to A? So we can do one thing. There is a standard rule. A1, L1. Okay, let me write it down. Okay, let it be in blue. A1, L1 is equal to A2, L2. Okay. So you elongated this wire to make it double its previous length. That means A into L is going to be how much? A dash into 2L. Cancel this L, you cancel this L. A dash is going to be how much, students? From over here, from here, this A dash is going to be A by 2. You'll get it how much ever you elongate it, that much ever your area will decrease. Okay, it's a standard rule, students. It's a very standard rule. Okay, now let's get into this question. Okay, we know another thing. Oh my goodness me, this is like A dash by 2. Okay, now I'm going to do an amazing thing. This thing, material has not changed. This is rho over here. This is also going to be rho. And what is R? R is like rho into L by A. So now let's say this resistivity is going to be a material property. It's going to remain the same. This is like R dash. How much is the value of R dash? R dash is going to be rho into 2L into divided by A dash. Basically 4 into rho into L by A. If you understood this point, it's basically 4. In this question you can have directly said it's 4R. Okay, double the elongation. So in this case, how much is R dash? R dash is going to be 12 ohms. Okay, R dash is 12 ohms. It's no more 3 ohms. Now what have you done? You have segregated this into 2 parts. Okay, and you're trying to find out the resistance between that. So you have okay, just assume this thing and this thing, and you have these 2 nodes A and B, and you're taken 60% of it. 60% of it is going to be how much? 2 ohms. Remaining is going to be like 12 minus 2, 10 ohms. Okay, how do we know this? This is basically R dash by 12. R dash by 6, it's 60 degrees, my mistake. 60 degrees, 360 by 60 by 360. Okay, that's it. So you'll be having like 1/6 of it, 2 ohms. Now coming to the next thing about this question, basically it's two parallel combinations, right? What do we have? We have something like 2 ohm, and then we have something like 10 ohm in parallel combination. That what we have? Yes. So that means what is the answer supposed to be? Basically resistivity is supposed to be 2 into 10 divided by 2 plus of 10, 12. Okay, I think there is a defined shortcut around this. How much are we getting? 5 by 4? Oh no, 5 by just a moment. 5 by 6, is that what we are getting? I'm somewhat confused. So this is like 5 by 3. So why did our estimate go wrong? 5r by 6. R by 6, 5r by 6. Yeah, we got 5 by 3. Well, speaking, I said 5 by 6. Is that what I said? 5 by 3, right? I think I said 5 by 3. Yeah. So RAB should be 5 by 3. Okay. I think the options don't have that. That's not a problem. But from the given options, you could have estimated. That's it. End of the story. So let's get into the next story then. Okay. It's again a very simple story. Not unlike earlier story. This is damn simple story. Trust me. In galvanometer, see how many questions just on galvanometer, voltmeter, and this time it is ammeter. Ammeter, what do? You shunt it. You shunt it. There is a super simple thing that you need to understand. That's it. So a resistance of a galvanometer is 50 ohms. The maximum current which can pass through it is 0.02 amperes. What should be the resistance? Okay, what should be the resistance that should be connected to it in order to make it into an ammeter having a range of 0.5 amperes? I'll explain you the concept. We'll get to the solution. It's a simple solution, simple concept. Nothing complicated in it. Literally nothing complicated in it. So let's say this is how much. Okay, not let's say, but this is how it works. So you have a galvanometer, like equivalent circuit of this galvanometer, and this galvanometer can only handle up until Ig. How much is Ig? 0.2 amperes. Sorry, 0.02 amperes, like 2 milliamperes. I'm saying. Okay, now you have a shunt resistance. Okay, you connect a shunt resistance in parallel. You need to remember this. Then what does this become? This whole circuit becomes an ammeter, because now it can handle more current, given that your G should be greater than that of your shunt. Okay, is there any hint around this? No hints. Okay, solve it. That's the hint. Now that means, let's say, let me do a thing. Let me draw another thing. This whole thing is going to be to have some. It's a very simple concept in this case. It's approximation actually. It's again an approximation. Generally, wherever applicable, apply the approximation if the values are very far away. Okay, in this case, if you notice, the values are far away, 10 order difference, and it's 2 order difference between these. So you can apply approximation as long as this values are jumping significantly. Okay, if it's not jumping significantly, then you need to be very careful. That hardly happens in your exam, so don't worry about it. It can be there in your practice exercise, etc. And this year I'm. Okay, now the thing is, here and between these 2 points, the potential is the same. And how much is this going to be? Your ammeter can handle some current. Let's call this to be IA. This is going to be how much? I minus of IG. Okay, let's keep it as I just, not IA, but A. Okay, it's a little difficult to write A in that inside that place. So what do we have? We know something. IG into G is equal to I minus IG into R. Okay. Now IG is how much? IG is 0.02 amperes. 0.02, like 2 into 10 to the power minus 3 amperes. Let's write it that way. That's quicker, that's simpler. Okay, that's pretty easy comparatively. 2 into 10 to the power minus 3 times, that is the easiest method. And G is how much? 50 ohms. And I minus IG is how much? We don't know. We have to find out. No, we know that it's 0.5 ampere, max to max 0.5 amperes. So basically 0.5 minus 2 into 10 to the power minus something like 2 into 10 to the power minus 3. I'm going to write it down as approximately 0.5. Basically 5 into 10 to the power minus 1. Okay, this is the shunt resistor. So this is going to be 100. This is going to be like how much? Minus 1. So you should be having a resistance of how much? 0.2 of how much? Okay, but one more important thing, if you have noticed during your mathematical calculation, if there is a 5 and 2 on one side, there should be a 5 and 2 if the values are jumping significantly. I'll come to that point, what I'm saying. Okay, simple way to guess your answer. I mean, if you're getting confused at the last moment, something has gone wrong. So you need to understand one thing. There is a 5 and 2 on one side, RG into IG. There should be a 5 and a 2, just in terms of numbers. Okay. And of course, there is 1 decimal. And how many decimals are over here? There are like 3 decimals. And if you remove this, it's basically 2 decimals. So you should be getting over here 1 decimal, 2 decimal, 1 decimal. 1 decimal, this is that one. Okay, that point, that is, even this way it's easy if you know the concept, basically understand the concept. How do you make an ammeter? You shunt something in parallel. You shunt a very small resistance in parallel. That's how you make an ammeter. This is how. That's why that is when the majority of the current will flow inside this. That's when you are increasing the range, isn't it? That's it. All right, let's do one more question or 2 more questions. So in a conductor, if the number of conduction electrons per unit volume is 8.5 into 10 to the power 28 per meter cube and mean free time is 25 femtosecond, its approximate resistivity is how much? A very interesting question, students. Very interesting question, because it's basically formula based question. So note down the equation that we are going to discuss. Okay, note down the equation that we are going to discuss. You need to find out resistivity, right? If you remember, how much is the resistivity? ME by NE square tau. Resistivity is mass divided by NE square by tau. Note it down. If you don't know this thing, note it down. That's it. That's all you need to know. Now there we go. We did the same thing, okay. And okay, here there is a row, and here there is a row. Okay, this is an equation given to you. Forget this equation, etc. Just remember this thing. Rho is equal to me divided by ne square tau. That's it. That's what we are doing. And what is femto? 10 to the power minus 15. Okay, femto denotes 10 to the power minus 15. I'm not doing the calculation. This calculation, I don't think even any kind of, approximate. That's it. Approximate things. Don't overcomplicate things to get the answer, because it's all 10 to the one like decimal differences there between each. So approximate things, you'll get the answer very quickly. For an example, I'll cancel out 9 and 8.5. I don't mind doing that. And I'll say 1.6 into 25 and twice, right? So that would be giving you something like 10, etc., because it's 1.6 whole square, and 1.6 is going to 2.56, so it's like 50, etc. So somehow we'll be approximating things very quickly. So this is going to be 38. You'll be going to be having 7, and then you'll be having you'll be having something like 10 to the power minus 38, 10 to the power minus 38, and this is going to be like 10 to the power minus 7, 10 to the power minus 7 goes off with this 10 to the power minus, okay, 10 to the power minus 6, 10 to the power minus 7, 10 to the power minus 22, 10 to the power minus 6, and you have something like 50 on the denominator. Okay, so if you don't want to do, you should not be doing even that detailed calculation. So this would be like approximately how much? 2 into 10 to the power minus 8. Multiply with 2 in the denominator, 2 in. Okay, this is one of the ways. You have the solution over here, but this is the way to go about it. Okay, I hope this is simple. This is a basic formula based question. We'll discuss this. There's a shortcut around this. We'll come to this point. We have many more questions, interesting questions coming up. Let's see if there is any that we can discuss now in the given time. No, this requires some shortcut. I'll teach you that shortcut in the upcoming. This also requires a shortcut. Okay, shortcut is you observe the least values, try it out yourself once. I think we're running out of time. We'll take it up tomorrow. And students, that being said, the coming Monday we'll be having a 10 years PYQ discussion along with your 2020 questions on your current and electricity on your Unacademy learning app. So don't miss it out. This is going to be a free of cost special class on your Unacademy learning app. So the content will be available for free. You can attend it live with polls and leaderboards. And if you missed it before, this is an ideal opportunity to attend and ask your doubts live from 10 a.m. to 1 p.m. This is going to be just the first session. So make sure you catch it up as soon as possible. We'll be also discussing shortcuts for your exam, especially if you have missed it before you can get started. And students, that being said, electrical measuring instruments in one shot is already completed on your Unacademy learning app in a single session. High probability, 95% probability, like hardly 3 sessions didn't get it out of 18 sessions. So that's like almost 3 sessions, 2 sessions didn't get something like that. So like 90% probability you will get a question from electrical measuring instruments, and we have discussed all of the concepts that is required, right, in a single shot, in a single go of 4.5 hours. So a very good topic to complete right now before your exams. So what all have we done? We have done everything: voltmeter, ammeter, potentiometer, Y potentiometer, how to apply potentiometer, to measure EMF, to measure internal resistance, to compare EMF, etc., and even least count based problems, etc., and try and cover even units, dimensions, and measurements. Students, very important chapter. And yes, least count based problems and end corrections, many more things, right? End corrections is also a thing. Okay, end corrections, least count error based problems, so many more things we have complete. Everything around electrical measuring instruments in a one shot of just 4.5 hours is available on your Unacademy learning app for free of cost. So complete it. And that being said, definitely very important chapter. Very important chapter. All you have to spend is one session, and probably you're going to solve even one question. So that's not at all a problem. And students, that being said, do get onto our Telegram channel. If you're not yet on our Telegram channel, download our Telegram, download the Telegram app from Google Play Store and App Store. And click on to this link which is available in the description box. Okay, you have an amazing link and of our Telegram channel. Just click onto this link, get onto our Telegram channel. Why you should get onto our Telegram channel? There are multiple reasons. The best reason is you will get before time updates on any classes conducted by our JEE English team, be it on your Telegram app, be it on your JEE English channel or your Unacademy learning app. So both places you'll be getting before time updates on our Telegram channel. Not only that, we keep you posted with updates, news, etc. about any of your exams on our Telegram channel. You can also check out by typing in JEE_English. So we have an amazing team of IITians and IITians and end of coaching institutes. So do definitely get onto our Telegram channel. And students, that being said, download Telegram app from your Google Play Store and App Store by typing in download Unacademy learning app from your Google Play Store and App Store by typing in Unacademy on your Google Play Store and App Store. Why should you have an Unacademy learning app? Because students, the best thing about an Unacademy learning app is you get access to many free of cost special classes. So the thing is, just get on to our Unacademy learning app, log in, you follow me. I keep conducting free of cost A to Z sessions, one shot sessions, PYQ session, etc., complete detailed lectures, full length lectures, and one shot, etc. And you'll be getting all of them, right? All of them, one shot, A to Z, PYQs, everything, access to everything that I've conducted for free of cost on your Unacademy learning app. So do download an Unacademy learning app and follow me to get those live updates. Not only that, you'll get access to free of cost quizzes, you'll get access to many more things like Unacademy Combat on Unacademy learning app. So it's an amazing app to have, and you can attend these classes from anywhere. Also, if you are a plus student, you are going to have many more advantages like attending classes from anywhere. And the most competitive gamified IIT JEE battle ever is going to happen again on 17th of January. So what is this? This is going to be a gamified experience with a national level crowd competing. We will have dedicated batches for 11th class, 12th class and droppers. So 13th class droppers. Okay. So we'll be having everything in a different format, different syllabus, and different competitions at the same time though. So if you are a dropper, if you are 11th class, if you are a 12th class, you don't have to worry about it. You're going to compete with some students of your preparation level. So yes, it's going to be the most competitive gamified IIT JEE battle ever, and it's going to be a national level test or a competition that you are going to attend, where you're going to have a quality paper set by the best educators. Not only that, you will also have access to these solutions in a very detailed manner. You will be posted out with detailed solutions, and students, it's going to be a very rewarding experience. So you'll be competing with some best crowd of the nation, but also along with that, you can win lots of prizes and rewards. You can compete live and win prizes and rewards. This includes Amazon vouchers, MacBook Air, Apple iPad, Apple EarPod, etc. And this is going to happen on 17th of January, this coming Sunday. So enroll today, students. Enroll today with Murli live code. Okay, enroll today with Murli live code so that you can avail the maximum benefits, best discount. Not only that, you can make use of Murli live code to unlock many features on an Unacademy learning app. This could be your Unacademy Combat, quizzes, many more things. You can unlock many features. You can avail best discount on your even combo subscription purchases. So make sure you use Murli live code whenever and wherever necessary. Wherever there is a space to apply the code, do apply Murli live code. And students, that being said, if you are looking for a complete package, a champions tool for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription. Why do we say that? because we have the best educators across the nation on this platform. We in fact have authors like DC Pandey and DC Gupta sir on this platform, and you can attend daily live interactive classes with the best educators across the nation. And you can also attend these classes on a very interactive platform with polls and leaderboards. That way your learning becomes interesting and fun. And moreover, students, you'll get access to lots of test series set by the best educators, and you're going to compete at a national level, based on which you'll be getting an analysis. You can make use of this analysis to improve upon your overall performance. And students, yes, of course, you will get access to lots and lots of live doubt clearing sessions. In fact, every program, every course is going to have the fourth session as live doubt clearing session, and you will also in fact have dedicated quizzes and mega quizzes with each program. So it's that overall complete package for your JEE Mains and JEE Advanced preparation. And not only that, students, it gives you unlimited access throughout the period. We do not restrict you by batches. So think about it. Unacademy subscription is one of the amazing things where you can attend these classes with the best educators, but you can attend it with multiple best educators depending upon your requirement. But anyway, 2021 aspirants, be careful what you're doing. You should be utilizing your time very wisely if you're on an academy subscription platform. So the thing is, like, you should not be, like going for 10 batches. We have dedicated batches for you, and even for 2022 aspirants, we have many dedicated batches by some of our best educators, like Bansal classes. And even for 2023 aspirants, we have classes that are going to be that are started by vibrant educators. So even some of the best coaching institutes are available. But the thing is, 2021 aspirants, you have to be specifically cautious about your time. I'm especially giving this advice because you have the time. If you have unlimited access, you can make use of it very wisely. If you move strategically, you will be able to easily complete your syllabus. So that is one of the things. You can start attending dedicated batches. You can attend courses that where you have left it incomplete. So these kind of things can be done on an academy subscription. It's going to be the best package, a complete a program for your JEE preparation. And students, how do you avail an academy subscription? You can do it from web-based version or an app-based version. Do download app because it gives you an advantage of having an app handy where you can attend the classes from anywhere. And if you are on web-based version or app-based version, just log in and then click on the left-hand top corner extension bar, select plus, and select IIT JEE as your goal, and hit on this get subscription. And students, yes, that's it. You will be having an amazing app, but now it will be like which package you should be going for, whether you should be going for 6 months, 12 months or 24 months. So it depends upon what you are doing right now, where you are right now. So let's say you are a 2021 aspirant and you have no plans for drop. So you're sure you're not going to drop anymore. So you can go for a 6-month package, because 6 months is how much time you have until your JEE Advanced, and this would be an ideal package for it. And how much is that going to cost you? Near about 25,250. And yes, as I told you, it's not just an amazing package, it's also an economical package. And let's say you go for a 1-year subscription. Who should be you? You should be like a 2021 aspirant who's sure that you are going to drop. Okay, or you could be a 11th class student who is sure that you have completed your 50% of the syllabus, and you'll be able to wrap up the 50% of the syllabus before your next before your JEE Mains, first JEE Mains. So how much is that going to cost you? It's going to cost you near about 34,650. That's less than 2,900 per month, 2,888 per month. And let's say you are a 2023 aspirant, or you are right now getting into 10th class, 11th class, etc. So this is the ideal package for you. Okay, and as I told you, we have also launched batch for 2023 aspirants. So make sure you avail the correct kind of thing that you need. A 24-month package is only going to cost you 50,400 for 2 years. So for a year, it's like 25,000. Okay, near about 25,000, less than 70 rupees a day. So this is about plus subscription. We have something beyond plus subscription known as iconic subscription. On iconic subscription, you not only get access to all the features of plus that we have discussed. Along with that, you'll be getting one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators on Unacademy. subscription platform. So what do you get by getting personal advice from them, and how efficient it is going to be? So think about it. IITian and NITians who have previously gone through this journey, who have cracked the exam successfully, they know ups and downs in this journey. So they will be guiding you with motivations. They'll be giving you that energy that you need for keeping up you throughout this journey, and as well as for your exams. And the next thing is, like, they know the strategies, they know what they have done during the time, so they will be able to exactly be guide you with those kind of personal advices based on your preparation, based on where you are. So we also have some of the best educators on Unacademy Iconic subscription, and what you can do is you can avail your personal advice for your preparation as well. So you'll be getting access to expert guidelines, like strategy sessions and motivational sessions from some of the best educators, and also IIT and NIT alumni on Iconic subscription at a very reasonable price. So if you go for a 6-month subscription, all it is going to cost you is 34,200. If you go for a 12-month subscription, it's going to cost you 58,500. If you go for a 2-year subscription, it's going to cost you like 45,000 per year. It's going to be like less than 50,000 a year. So anyway, make sure you apply Murli live code, be it you go for a 6 months, 12 months, 24-month plus or Iconic subscription, so that you get maximum discount on your subscription purchases. Don't miss out any discount. If you don't see this pricing, do apply Murli live code so that you can get maximum discount on your subscription purchase. And not only that, do apply Murli live code whenever and wherever necessary. And recently we have introduced something known as combo subscription, student. What is this combo subscription? On combo subscription, you not only get access to like just IIT JEE lectures, but also you can prepare for your CBSE board at a very economical price. It depends upon which kind of combination that you want to go for. It's a combination of IIT JEE and CBSE preparation in one place. So a combo subscription can start anywhere from 3,000 rupees, less than 90 rupees a day. It depends upon what kind of combo subscription you're going. So let's say you're going for a Iconic IIT JEE subscription and plus of a CBSE, it's going to cost you 4,687 per month. So if you're going for a full Iconic subscription, Iconic of IIT JEE, Iconic of CBSE, and it's going to cost you like 5,500 per month. And let's say you're going for plus and plus. Plus of IIT JEE, plus of CBSE, of course the most economical one is going to be this. It's going to cost you 3,037 per month. And let's say you're going for plus of IIT JEE and an Iconic of CBSE, and we have some of the best educators for your CBSE board preparation on Unacademy. So if you go for this, it's going to cost you 3,900 per month. So students, that way you can avail both the subscription at an economical price. And anyway, the Murli live code is applicable on combo subscription as well. Don't miss it out. Do apply Murli live code even during your combo subscription purchase. So make sure you're applying Murli live code so that you're able to get maximum discount. Don't miss out discounts. Of course, if you don't see this pricing, apply Murli live code, you'll get to this pricing. And that being said, we have two interesting payment options that I typically recommend to students. One is pay in parts, and the other one is like no cost EMI. So using these two payment options, you don't have to pay all the fee at once. You don't have to go through the hassle of paying all the fee at once, and you can split your payments into multiple parts, and you don't have to worry about paying it all at once. And we do also have access to debit card, credit card, UPI, net banking, etc. on Unacademy subscription platform. And students, right now our team, JEE English team, is also available on Iconic subscription. You can take your JEE preparation to next level with our personal coaching, and you can get our access to our IIT JEE workshop, expert guidelines, and many more things on Iconic subscription in language of your preference. It can be Hindi, English, or any other language that we can speak. And that being said, in this January we have launched some batches for 2021 aspirant, and that is one is like Super JEE 2.0, and the other one is Striker batch 2.0. So you may want to check out both of them. And we have also launched an advanced micro batch for 2023 JEE mains and advanced aspirants, and that is being conducted by vibrant educators. So make sure you are enrolling as soon as possible. It has just recently begun. If you are 2023 aspirant and 2021 aspirant, we have dedicated batches for you. And we have launched an RM for 2022 aspirant JEE mains and JEE advanced, and we have launched legend classes for again JEE mains and JEE advanced 2020 aspirants by Bansal educators. and make sure you're enrolling soon, students. And these are some of the upcoming test series in January. As you know, Unacademy Combat is going to happen on this coming Jan, and we will be also having another one on 31st of Jan, and we'll be having an Unacademy race on 10th of Jan and 24th of Jan, and we'll be having a last mile target which has happened on 9th of Jan, and similarly another one will be happening soon. And we have this AIM 2021 every Saturday, and unique DPPs happening every Monday to Thursday. And students, yes, we have launched a Manzil batch and Rank Booster 2.0 batch for 2022 and 2021 aspirant, conducted by some of our best educated team. And students, do not forget to like, share this video, do share it on your social media with your friends, on your WhatsApp groups, on your Telegram channels, so that let them get access to this free of cost high quality content. And this is the time that JEE is coming up, so do definitely share it with your friends and hit on that subscribe button and bell notifications. Do not forget to do that so that you get timely notifications. So share it and keep smiling, avoid gossips, and work hard and smart to achieve your success. And that's why we have this PYQ session. So it's not always about hard work, it's also about smart work. And avoid any gossips, keep smiling, students. Nothing is better than, you move with a very like a optimistic attitude. And that being said, students, yes, tomorrow again at 6 p.m. we are going to get started with PYQs of gravitation. Don't miss it out. So this is something that we are going to do, and of course we'll be having this current and electricity PYQ continuation from 7:30. Okay, from 7:30 we'll be having your this PYQs, that is like current and electricity PYQs, that will be continuing as usual. Okay, and make sure you apply Murli Live code whenever and wherever necessary while purchasing Unacademy subscription or unlocking any feature. Take care, stay safe, bye bye, see you in the next session with many more concepts.